Welcome to IVJ channel. In this class, we discuss about simple harmonic motion. So, ఈ క్లాస్లో మనం ఫిజిక్స్లో సింపుల్ హార్మోనిక్ మోషన్ గురించి డిస్కస్ చేద్దాం. ఇది జూనియర్ ఇంటర్మీడియట్కి వస్తుంది. సో సింపుల్ హార్మోనిక్ మోషన్ So in this class, in simple harmonic motion, we discuss what are the concepts present in it. So write the concepts. First, introduction. Discuss about introduction. Means about the motion of bodies. How many types of motion of bodies are there? So in that first one, introduction. Next one, periodic motion. So in periodic motion, we define about the periodic motion definition. Study చేస్తాం. తర్వాత how many types of periodic motion are there? So two types of periodic motions are there. One is rotatory motion or circular motion. Second is oscillatory motion or vibratory motion. వాటి గురించి స్టడీ చేస్తాం. సో oscillatory motion, అయితే మనం సింపుల్ హార్మోనిక్ మోషన్ గురించి డిస్కస్ చేస్తాం. దట్ మీన్స్ వీ డిస్కస్ అబౌట్ ది సింపుల్ హార్మోనిక్ మోషన్. సో యాక్చువల్లీ పీరియాడిక్ మోషన్స్ ఆర్ క్లాసిఫైడ్ టూ టైప్స్. One is oscillatory motion, second one is rotatory motion or circular motion. But simple harmonic motion it comes under oscillatory motion. So we discuss about oscillatory motion. And about rotatory motion or circular motion, it is another topic. Next one. Analysis oscillatory motion. Next one. Analysis simple harmonic motion. It's an oscillatory motion is nothing but simple harmonic motion. So analysis of simple harmonic motion. Next one, equation of equation or characteristics of simple harmonic oscillator or in simple harmonic motion, or characteristics of simple harmonic oscillator. Next, time period. We discuss about time period. Time period means capital T. That means the time taken to complete one oscillation. Time period గురించి స్టడీ చేస్తాం. Characteristics. So characteristics అంటే oscillatory motion, whenever a body executing oscillatory motion, that there exists some extreme positions, mean position. So another one amplitude, time period, frequency, ఇవన్నీ స్టడీ చేస్తాం. So those are the characteristics of simple harmonic oscillator. Time period. So equation of a simple harmonic oscillator. Equation of a simple harmonic oscillator. Equation of a simple harmonic oscillator. తర్వాత in this we discuss about linear simple harmonic oscillator and angular simple harmonic oscillator. Means types of oscillators, oscillatory motion. So types of oscillatory motion. Is linear simple harmonic motion. Second one angular simple harmonic motion. Next, when our body is executing simple oscillatory motion, what about the force? In that force, we get about the definition of restoring force. Restoring force. Restoring force next automatic resistive force. These are no problem. I'll get anywhere. Restoring force. Next, what about energy? Variation of energy. How the energy varies in simple harmonic motion. Energy in a simple harmonic motion. Energy is conserved. Energy in simple harmonic motion. Energy. And a simple harmonic oscillator. Okay. So in there are two or more springs are connected. So what about the time period or frequency? That means springs are connected. Combination of springs means connection of springs in two ways we can arrange. That means a combination of springs. So and that combination of springs. Combination of springs. Then what about time period frequency? Time period frequency, energy variation, variation of energy. ఇవన్నీ ఇంకా స్టడీ చేస్తాం. ఓకే నోట్. నెక్స్ట్ ఒకటి నెక్స్ట్ ఆసిలేషన్స్, ఫ్రీ డాంప్డ్ ఆసిలేషన్స్, ఫ్రీ డాంప్డ్ ఆసిలేషన్, damped and forced oscillations. వీటి గురించి మెయిన్గా. So we discuss in this simple harmonic motion we study about first we discuss the introduction. What is simple harmonic motion definition? Next periodic. What is periodic motion? So periodic motion is can be for two types of oscillatory motion. Another one circular motion. So in this case, in this simple harmonic motion, we discuss about oscillatory motion and also simple harmonic motion, characteristics of simple harmonic oscillator, time period, equation of simple harmonic oscillator. So types of simple harmonic motion: linear simple harmonic motion, angular simple harmonic motion. And next, restoring force, energy in simple harmonic motion. Energy is conserved in simple harmonic motion. So that means total energy becomes equal, means potential energy and kinetic energy will be exist, but sum of potential energy and kinetic energy equal to total energy or total mechanical energy. Combination of springs. So springs how can we arrange in two ways? One is series combination, second one is parallel combination. So in combination of springs, series combination, parallel combination, how the time period varies, frequency varies, energy varies. Next, free damped oscillations, forced damped oscillations, we can discuss about those. Next one. So we discuss about periodic motion. First, what introduction? Next, periodic motion. Periodic motion. First introduction. So bodies can move from one place to another place at the time is going on. If on application of force on a body, it displaces from its position. Means it moves from its initial position to final position. So we can say that as the time is going on, the position of the body is changing. Means the body is said to be in motion. So the motions are different types. Suppose the body is moving along a straight line, that is a linear motion, you can say. Suppose the body is moving in a circular path, that is a rotatory motion or circular motion. So if your body is moving from its initial position to final position and is come back to its original position along the same path, so that is oscillatory motion. If your body is moving along the if the motion of a body is repeating, so it reaches to the same position and it is moving on the same path. So that motion is called circular motion. In a regular interval of time, if the path is repeating, the motion is called periodic motion. So different motions are there. If a body can exist, the motion of a body is exists in different types. So motion is so motion of our bodies along straight line may be curved path or circular path or elliptical path. Okay. So there are so many are there, different types of motions are there. Now what about periodic motion? So motions. Periodic motion. Periodic motion. Periodic motion. So what is the definition of periodic motion? The motion of the motion of a body or a particle, motion of a body or a particle is repeating at regular intervals of time. At regular intervals of time, then the motion is called periodic motion. Okay. Now, what is a periodic motion? Just I am taking an example. We are considering an example. Earth is revolving around the sun, and in the same path it always rotates. Always the motion of the earth is along the same path. So and it repeats in the same interval of time. Suppose the earth is at starting. Consider the earth starts at one position. It rotates about the earth and reaches to its same position. That means it completes one rotation. It completes one circular motion. So it will take some time now. The time taken to complete one circular or one circle motion or one rotation is called time period. So again it will not stop. It will rotate the same path and it will take the same time. And again it will move along the same path, in circular path or elliptical path. So it takes the same interval of time. So we know, everyone know in our lower classes we got that the earth revolves around the sun in an elliptical path. Okay. So that is that comes the motion of the and the motion of the earth is called periodic motion. One more example if we discuss rotation of the grinder తీసుకున్నాం అనుకో, గ్రైండర్ ఏమవుతుంది, రొటేట్ అవుతూ ఉంటుంది. ద సేమ్ వే ఫ్యాన్ రొటేట్ అవుతూ ఉంటుంది, సీలింగ్ ఫ్యాన్, టేబుల్ ఫ్యాన్, వాట్ ఎవర్ ఇట్ మే. సో ద మోషన్ ఆఫ్ ద ఫ్యాన్ ఆర్ ద మోషన్ ఆఫ్ the fan inside the motor. In motor also exists, the fan exists, it rotates in circular path. Okay. So the wheel whenever the bike is moving, the motion of the whenever the bike is moving, automatically the wheel rotates in circular path. The motion of that wheel is nothing but rotatory motion or circular motion, cycle motion. So same. So that motion is called periodic motion. So the path is repeated in regular intervals of time. So the motion of the particle or a body is repeating at regular intervals of time. Then that motion is called periodic motion. So periodic motion, how many types are there? Motion of periodic motions are classified into two types. One is circular motion or rotatory motion. Second one is oscillatory motion or vibratory motion. So it is classified into two types. It is classified into two types. Two types. One is circular motion or rotatory motion. Second one is oscillatory motion or vibratory motion. Okay, but in this topic, in this class, we discuss about simple harmonic motion. So we discuss about oscillatory motion. So here, what about oscillatory motion? Oscillatory motion comes under periodic motion. So we discuss about oscillatory motion in this case. Now write oscillatory motion. Oscillatory motion. What is the definition of oscillatory motion? Take, I am giving an example. Take a wall clock. If you consider a wall clock, the pendulum of a wall clock moves towards another one side, and it comes back to mean position, and come back and reaches to another position, and again come back to its mean position. Again it moves to other end. Again come to mean position or middle position. Again moves to other side like this. So it is what is happening. How do we define oscillatory motion? So here the to and fro motion of an oscillator is called oscillatory motion. See here definition. The to and fro motion, the to and fro motion of an oscillator is called oscillatory motion, or oscillator అనొచ్చు, లేకపోతే బాడీ ఆర్ ఏ పార్టికల్ is called oscillatory motion. Okay. So for this example, take a wall clock. So wall clock, how it will be? This is a wall clock. Let it be. Wall clock pendulum. This is a pendulum. Okay. Now this moves. So this totally in a like this. Okay. Now this is let it be rest position or equilibrium position, mean position. Equilibrium position. Equilibrium or mean position. Next, it comes to one end position, means one position. Let it be like this. Okay. Now this position is called here. Okay, like this it will be. Okay. Now this position, this is end position. Again it comes back to its original position. Again it comes to this position. So this is one end position, other end position. ఇది టోటల్ బార్ క్లాక్ వచ్చేసి. So automatically this is end position. This end position is called extreme position. This end position is also called extreme position. What is this called? Mean position or equilibrium position. So if it starts from one end or A position A, it reaches to position B. So the motion of the oscillator from one end to another end or from A to B is called two motion. And whenever release from this, initially if we release the pendulum from position A, it will not stop at anywhere, even though at position O, let it be mean position, or M, let it be O, this is. Now M, this is. It will not stop at M. It moves to other end or other extreme position. So from A to B, this is the motion is called two motion. This A is extreme position, B is also extreme position. And again whenever it reaches to B position, it will come back to its A position. From B to A, that motion is called flow motion. That is a flow motion. So it finally reaches to initial position or starting position. So one two motion plus one flow motion is called one oscillation. This motion is called oscillatory motion. This motion is called oscillatory motion. So the time taken to move from A to B and come back from B to A, that means is called time period. That means the time taken to complete one oscillation is nothing but time period. Okay? Yes. Note down this one. Continue in the next class. Continue in the next class.